Welcome to our tutorial on implementing a face recognition system for lost and found applications. In this session, we'll explore how to use Java to develop a reliable system that can help reunite lost items with their owners using facial recognition technology. Before diving into the code, let's discuss the core components we need for this project. We're going to use Java along with a couple of powerful libraries: OpenCV for image processing and face recognition, and a simple database like SQLite to manage our records. Let's get started by setting up our project. Make sure you have Java installed and your favorite IDE ready. Begin by creating a new Java project. Next, we need to add the OpenCV library to our project. Download the latest version of OpenCV from the official site. Once downloaded, extract it and copy the openxxx.jar file into your project's libs directory. After adding the OpenCV library, don't forget to configure your IDE to include it in the build path. For example, in IntelliJ IDEA, you can do this by going to Project Structure-Libraries and adding the .jar file you just copied. We also need to include the SQLite JDBC driver to handle our database operations. Download it from the official SQLite JDBC repository and add it in the same way as the OpenCV library. To manage our data systematically, we will create a simple SQLite database to record faces and their related information. Let's define a simple database schema. We will have a table named lost_items with fields for ID, image_path, and owner. Now, let's set up our Java class to interact with the SQLite database. Create a class named DatabaseHelper. This class will handle the connection to the database and allow us to perform CRUD operations on the lost items. For face recognition, we'll be using OpenCV's HAR Cascade classifier. OpenCV provides pre-trained models for face detection which we can utilize without needing to build our model from scratch. Let's ensure to download the HAR Cascade XML file from OpenCV's GitHub repository. Now, let's create our main class named Lost and Found App. We'll initiate OpenCV and set up our face recognition functionality. Start by loading the HAR Cascade for face detection. Next, we will implement a method to process images and detect faces. This method will take an image file path as input, and if a face is found, it'll save it into a new location for later recognition. Now we need functionality to register lost items. We'll create a method within Lost and Found app that combines the face detection with database storage. This method will take the owner's name and the image path, detect the face, and save it to the database along with the owner's name. Now, let's test the registration process. You can create a simple console interface to allow the user to input their name and the path of the image file they want to use. This will enhance user interaction with our app. Next, let's implement the face recognition feature. For this purpose, we'll need to compare a new image against our saved images in the SQLite database. For simplicity's sake, we'll reduce this complexity by using known features or embeddings. In our actual implementation, you would need to load the previously saved faces from the database and run a comparison algorithm, which could be something like Euclidean distance or cosine similarity between the detected face embedding vectors. For demonstration purposes, we'll create another method in the Lost and Found app class to handle the recognition process. It will prompt the user to input an image to check against the existing database of lost items. In the main method, you can add another prompt for recognition to allow users to search for their lost items. Finally, let's bring everything together and see it in action in our application. Once you've integrated all the pieces, you should be able to register a lost item and find it using facial recognition. When running the application, if everything is configured and coded correctly, you should see console prompts allowing you to register and search for lost items by uploading images. Remember to handle exceptions and edge cases in your final application, such as invalid image paths and missing user inputs, to make your application robust and user-friendly. As we wrap up this tutorial, remember that while face recognition technologies are powerful, ethical considerations must also be taken into account when deploying such systems in real-world scenarios. Thanks for watching. Make sure to subscribe for more tutorials like this, and feel free to leave a comment if you have questions or need help with your own implementations. Happy coding!